Hi everybody. Today we're going to solve some more equations. Aren't you excited? So here we go. Here's the equation. And first step, of course, using the red poster, first thing is to draw the line from the equal sign, circle the variable, and then we're going to check to see if there's anything to simplify. From today on, there may be things to simplify. Sometimes there won't be, but sometimes there will be. So always check this extra step in here before you start undoing math. So draw the line through the equal sign, circle the x. Now I'm going to check to see if there's anything to simplify. So when you simplify, you only simplify one side of the equation at a time. So you can either do the right side of the equation, and then you go check the left side to see if you can simplify that. You don't simplify across, you just simplify one side only, and then go to just simplify the other side. Okay, so this is not the undoing part, so don't be doing that. So if I cover up this side and look at the right-hand side of the equation, 22. Is there any math I can do with that 22? Do they tell me to do anything? No, they don't tell me to add, subtract, or multiply or anything. So there is nothing to do on that side. There is no simplifying for me to do. Single number, can't do anything. Left side. Well, I see some operations to do over there, but it's got parentheses in it. So I'm thinking, maybe I should follow PEMDAS and do what's inside the parentheses. And I'm thinking, great idea. Let's go do PEMDAS and do inside the parentheses first. So x minus 4. Can you combine the x and a negative 4? Are they like terms? Nope, you're right. They are not like terms. So I cannot do what's inside the parentheses first. Normally I would do that and then take that answer times a 2. I can't do what's inside the parentheses. But how can I get rid of parentheses when I can't do what's inside? There's something that lets me do that. Can anybody remember what the name of that is that lets me do that? Yes, you're right. It is the distributive property. So I'm going to take the number in front and multiply it times everything inside. So 2 times x, and there's a 1 sitting there in front of this, so 2 times 1 is 2, and I still have the x being multiplied with it, and 2 times negative 4. Positive times negative, the signs are different, so the answer will be a negative number, and 2 times 4 is 8, equals, and then the 22. Okay, so far I got rid of the parentheses. Poof, they are gone. I rewrote it now with no parentheses. Check, can I combine like terms? No, they are not like terms, so this is where you stop with the simplifying part. Now that the simplifying is done, I can move on to isolating the variable. This is where we start undoing things. So here's the variable still over here. There's the x, and I'll circle it again just so we can see it. I need to get rid of the 2, and I need to get rid of the negative 8. Which one should I get rid of first? PEMDAS in forward order or PEMDAS in reverse order? Yep, in reverse order. So normally you would multiply first and then subtract. So I'm going to undo the subtraction first and then undo the multiplication. So how do you undo subtraction? Add an 8. That's the inverse operation. If I do it to one side, I must do it to the other side. You're right. Draw your line. We're going to rewrite the whole thing. Of course, the 8's canceled out because a negative 8 and a positive 8 means I'm adding 0 to this problem, and adding 0 won't change anything. So 2x comes down. That's why they canceled. 22 plus 8, do that math. You get a lovely 30. Is x by itself? Nope, not yet. So keep going. This operation, what's happening between the 2 and the x? Multiplication. What's the inverse operation of multiplication? Yep, division. So divide this side by 2. Whatever I do to one side, I must do to the other side. The 2's cancel out because 2 divided by 2 is 1, right? Just a single 1, and 1 times x is still x. You can put the 1 in front of it if you want to. Don't have to. Equals 30 divided by 2, 15. And there is your answer. X is equal to 15. Now, could you check your answer? Yes, on test day, I would want to check it to make sure it's right. If x is 15, 15 minus 4 is 11. 11 times 2 is 22. Is that what the number is supposed to be? It is. I am correct. Yay, doesn't it feel good when you get one right? Okay, let's go do another one. That was number 1. Make sure you are copying this whole thing down on your paper. Remember, you get to pause the video when you want to and go back and listen to it again. Make sure you're showing the signs, draw the line, circle the variable. Make sure you wrote your name on your paper too, so when you take a picture, I'll know it's yours just in case it gets mixed up in the computer somewhere. Anyway, make sure you're showing the work. Put your heading on your paper. Let's do I'll let you do 2 and 3 on your own. Let's go do number 4. 4 looks really interesting. There's a picture. I love pictures. I love geometry. It's just so fun. This is the type of stuff you'll be doing next year in geometry. We're going to learn the solving process this year, but then you're going to use your geometry to make equations. Okay, this one says solve the following problem. The perimeter is that, and they give me a lovely triangle. They give me this information here, and then they want me to find Q. So I want to find Q, but normally when we're solving, they give me an equation. Did they give me an equation? I see an equal sign, but it's not really it's got numbers on this side, but it's got words on this side. So I'm kind of thinking, So if they don't give you an equation, you have to write your own equation. But they're going to give you enough information that you can do that. So let's see what we got here. They give me this little figure, and they have little hash marks on here. Those hash marks mean that since there's a single mark, single mark, single mark, all three sides have the same length. Okay, they're the same length. If they had given you a picture that looked like this, that means these two have a single mark, they're the same length, but this one has two marks, meaning it's a different length. Okay, so because all three of these are the same, this is an equilateral triangle. All right, all three sides are the same. Now, I see they told me that this side over here can be found by taking 2q minus 3. So 2q minus 3 is this side. So I'm still kind of figuring out what to do here, but it says the perimeter. Who knows what perimeter is? Yes, you're right. Perimeter is the distance around the triangle, right? And I get that by adding this side plus that side. And it's going to equal what? I think that's how I can make my equation. So one way to do it is to say this is 2q minus 3. Now, I put this in parentheses because it will help when you get into some other crazy problems that you'll be doing in the future. So this whole side, if I do that math, that would give me a number, right? So 2q plus 3, one side plus another side plus the third side. Okay, so make sure I have enough. 1, 2, 3 sides equals 21. So there's my equation, and I could solve that. It's actually very simple to do, and we're going to do that in just a second. Now, some of you may be thinking in your head, oh, wait, Ms. Harris, I know another way to write this equation. Yes, there is another way to write this equation. If you were thinking, well, since there's 3 of those, couldn't I just simply say 3 times 2q minus 3? I could add them all up, 1, 2, 3, or I could just say 3 times it, right? And that's going to equal 21. Either equation will get you the exact same answer. So either way you do it, you're right. Okay, so let's do this one first. I have parentheses, I want to start from the beginning. Draw the line through the equal sign, circle the cube. It's over here. Simplify first. Anything on the right side to simplify? Nope. Anything on the left side to simplify? I see parentheses, so I'm thinking let's simplify. Yeah. So inside parentheses, can I do this math? Can I add a 2q and a negative 3 together? Are they like terms? Nope, they're not. So when I can't do what's inside the parentheses, how can I get rid of those parentheses? Yep, distributive property. 3 times 2. There's your 6, and you have a q still being multiplied times it. 3 times the negative 3 is a negative 9. Parentheses are gone, which is what I wanted, equals 21. Still nothing to simplify on the right, and I check to see, can I combine those? Nope, not like terms. So at this point, I'm done with the simplifying part, and if you notice, we're back to a 2-step equation, which is kind of nice because we know how to do those. Here's the q again, just to remind you where it is. We got to get rid of the 6 and the 9. Which one do we get rid of first? Yep, you're right. You're going to get rid of the negative 9 first because we go in reverse order when we're solving, right? So if normally you would have multiplied first and then subtracted the 9, we're going to undo this one and then undo that one. So since that's subtraction, with opposite operation is add 9. That's the inverse. If I do it to one side, I must do it to the other side. And then we're going to rewrite that whole equation. Give it a whirl. See what you come up with. Go ahead, you can do it. And then you can check in a second. I'll do it up here too, but you can pause the video and go do it yourself, see if you get the same thing I do. Okay, if you join me back up, negative 9 and positive 9 cancel out. Gives you a big old 0 there, so you're adding 0 to the 6q. So 6q is equal to 21 plus 9, of course, is 30. Is q by itself? No, it's not by itself. However, how do we get rid of multiplying by 6? Yep, the inverse operation of multiplication is division. So we're going to divide by 6. If we do it to one side, we do it to the other side. I'm going to move over here for the final answer. The 6's cancel out. Q is equal to 30 divided by 6, 5. Boom. Now, I do want to point out, Q over here, they asked you to find Q. Q is 5. Is 5 the length of the side of this triangle? Side of the triangle is 2q minus 3, so it is not. So you always want to pay attention to what the questions ask, because sometimes they don't stop with this. They will say, oh, what is the length of the side? In which case, then you would plug it in. 2 times 5 is 10. 10 minus 3 is 7. So the length of the side is actually 7. So, excuse me. Oh. I swallowed wrong. Anyway, so Q is 5. So just double check it and make sure that the answer that you got is actually the answer to the problem, and you don't have to go a step further with that. Okay, so there was that one. Now some of you may say, oh, well, what if we did it the other way? This has, you've got to get rid of these parentheses because you can't do what's inside. There's a positive 1 sitting in front of each one of these. And when you distribute a positive 1, 1 times 2q is still 2q, 1 times negative 3 is still negative 3. So you could rewrite this, but now when you rewrite it, the parentheses are now gone, right? And 1 times that is still that, and 1 times negative 3 is still negative 3. So if you rewrite this step, I'm not going to do the rewriting step just because I'm running out of room. The parentheses are now gone. Same thing here, 1 times that, 1 times that. But you kind of go through the process. Does it change or does it stay the same? It stayed the same, so I can just ignore the parentheses. So now like terms, 2q, 2q, 2q. What's 2 plus 2 plus 2? 6q. Same thing that I got here. Negative 3 plus negative 3 plus negative 3. Bad guys, bad guys, bad guys. A lot of bad guys. So 6q minus 9 is the same side again over here. So either way you did it, you got the same answer. Isn't that fun? I just love that about math. It just makes me feel so calm to know that everything is going to come out to be the exact same answer. Anyway, let's go do another one. That was number, I don't know, what was it, 4? Okay. We are going to look at number 5 together. 5 is a lovely word problem. So I kind of scan it. And usually, actually, what I do is I read the question first at the very end and then go back. There's a hint here. It says write an equation that says how many students were in each bus. So I want to know how many students were in each bus. So now I got to go back and read it. Yeah. 331 students go on a field trip. 6 buses were filled, meaning they were completely filled up, no empty seats available. And 7 students traveled in cars. How many students were in each bus? Yeah. Oh, that swallowing thing's going to be a while to go away. Can't write an equation to solve. So, we need to write an equation. So I'm thinking, okay, I'm looking for how many students were in the bus. So I'm going to let my variable be that I'm looking for is the number of students in, bus. Oh, I know that was really bad writing there. In a bus. Okay, so X is going to be my number of students in the bus because that's what I'm looking for. All right, so when I solve the equation, I'll have my answer. So here's my number of students in the bus. How many buses were there? Yep, 6 of them. So if I do 6 times however many students are in a bus, will that give me the total number of kids on the buses? Yep. Were there any extra kids? Yep, 7 more. So plus 7 in the cars. And how many students were there all together? Yep, the total equals. So total equals adding, and then the total amount of there obviously equals the 331 students. That's all the students. Can you solve that? I'm pretty sure you can. Go do that. I'm going to move on to another problem. I'll just solve that. Okay, number 6. Number 6. This is an interesting one just because the variables are a little interesting in this. They do this a lot in a lot of physics formulas and science formulas and things. But we're solving this lovely equation, and when I look at it, I see a whole bunch of variables. So again, they have to tell me which variable to solve for. And they did. They told me to solve for A. So draw the line through the equal sign, circle the A. That's the goal, is to get A by itself and get everything else to the other side, right? So when I look at this, you see a V and you see a V sub 0. V sub 0 is just another way they could have said, I have a variable A, a variable B, a variable C, or they could have said, I got a V, I got a V1, and I got a V0, or a V2. They kind of use numbers sometimes instead of different variables. So there's a variety of reasons that they'll do that. But anyway, without getting into details on that, these are 2 different variables. Okay, that's the important thing there. So the goal is to get A by itself. I need to get rid of this V sub 0, and I need to get rid of the T. Which one first? Yep, reverse PEMDAS. So I'm going to undo the add subtract one first, and then I'll undo that multiplication part. So this right now is a positive V sub 0. So I'm going to subtract a V sub 0. If I do it to one side, I must do it to the other side. And then I'm going to got the whole thing. So obviously they canceled out over here because adding and subtracting the exact same thing is like adding a 0. So this is A, T is left, equals. Now these are different, so they cannot be combined together. So this is going to be V minus V0. Just write them side by side. They are not like terms, okay? Now, the T is still over here. I got to get rid of this. No, yeah, the T is still over here. I need to get rid of the T because A is what I want to leave by itself. I circled the A to remind myself which one to get by itself. So, how do you do multiplication? Yes. Inverse of that is divide. So divide by t, and this whole side gets divided by t. T's cancel out. So when you rewrite this, you have a is equal to v minus v sub 0 on top over t. Now, you'll probably see it like that on the answer sheet. They may occasionally split it up and have v's, because this distribution here for division, this division line means this piece gets divided by t and that piece gets divided by t. So they could show it in that form, v divided by t minus v sub 0 divided by t. So this piece being divided by t and this piece being divided by t. So either way, you may see that on the answer choice. They won't give you both of them, they'll just have one of those available for you to pick from on the answer choice. Okay, so there's that one. I got one more we're going to do together, and that's number 12, and you will get to do the rest of them on your own, because you need some practice. But aren't these fun? I just love doing these. I could do these all day long. Ah, it's so comforting. Number 12. Let's go look at number 12, because this looks really interesting. Solving again. Here's the equal sign, so draw the line through the equal sign. That gives me my 2 halves of the equation. Whatever I do on one side, I must do to the other side. Remember? So that tells me what the 2 halves are, even though it looks out of kilter, but that's where the division line is, that's where the equal sign is. Okay, so there's the 2 halves, and then circle the variables. Do you see some variables up there? Yep, I see a W here, I see a W here. They're both W, so it is just one variable. Okay, I just need to simplify, because obviously there's a whole bunch of stuff on this left side, so we're going to simplify the left side a lot. Is there anything to simplify on the right side if I ignore this? No, just a single number, so I don't need to simplify anything on the right, but I do need to simplify the left. And when I look at this, I see parentheses. I want to get rid of parentheses when I'm simplifying. So check to see, can you do what's inside PEMDAS? Do the parentheses first. 12W plus 15, are they like terms? Nope, can't do what's inside. Let's check this one. Negative 3W minus 4, are they like terms? Nope, they're not like terms, so you cannot do what's inside parentheses. So how are we going to get rid of the parentheses when we can't do what's inside? Yes, distributive property. We are going to multiply this number sitting right in front times the first piece. And this is only going to be multiplied times this parentheses only. So you're going to stop when you get to the end of the parentheses. So 2/3 times 12. So again, you can do that in the calculator, or you can practice doing it in your head, or going without it. So if you put the 12 over 1, you've got 2 times 12 on top, which is 24. 3 times 1 on bottom is 3. That's 24 divided by 3. Yep, that's an 8. So this little math here became an 8W. And they're both positive, so it is a positive 8W. And then 2/3 times 15. So I got 2/3 on top and 15 over 1 on that one. So 2 times 15 is 30. 3 times 1 on bottom. 30 divided by 3 is 10. And it's both positive numbers in the problem, so this is a positive answer, 10. That parentheses is now done. Boom, finished. So now I need to distribute this one. So what number is sitting in front of that parentheses? Is there a number in front of that parentheses? They didn't write it, but is there one there? There actually is one there. Yep, you're right. I heard you. It's a 1. There's a little 1 sitting right there. So I'm going to multiply a -1 times everything. I'm going to distribute that -1. Negative times negative is a positive 3. Negative, oh, don't forget the W with it. And then negative times negative is a positive 4. And that equals -8 over here. So far, all I did was get rid of the parentheses, because when I did that distribution and rewrote it, parentheses were gone. But I'm not done, because I still see a whole bunch of stuff over here. So I'm thinking, like terms? Could there be some like terms? Yep, you're right. You saw them. I got a 10, I got a 4 up here. So 8W plus 3W. That's easy. They're both positive 11W. Good guys and good guys. Positive 10, positive 4, just adding those together, 10 plus 4, 14. Good guys and good guys. I got a lot of good guys. Equals -8. Now at this point, it's back to a 2-step problem. Here's the W. I got 11 and a 14 to get rid of. Which one first? Yep, the 14. We're going in reverse order. So subtract 14 on both sides to undo those. Opposite operation, the inverse operation of addition. If I do it to one side, I must do it to the other side. How many times have I said that so far? It's getting to be a lot by now. Okay, so the 14s cancel out. That's why we did it. 11W comes down, equals, do the math, bad guys and bad guys. I got a whole bunch of bad guys. How many bad guys do I have? Yep, 22 bad guys. Oh, it's nice when you see these numbers and you go, oh, it's going to be a pretty answer. How do you undo multiplication? What's the inverse operation? Yep, division. Divide by 11 on one side, you must do it to the other side. Here go. The 11s are going to cancel out. Bring the W down, equals negative divided by positive. Is the answer going to be positive or negative? Yep, it's negative because the signs were different. So negative 2. 22 divided by 11 is 2. So W is equal to a negative 2. And you can absolutely plug a negative 2 in there. Do the math in the parentheses times 2/3. Plug a negative 2 in here. Do the math inside the parentheses. Multiply times a negative 1. And then add those two together, and you will get a negative 8. So you can always check it with the calculator if you want to, or just go through the math step by step without a calculator. Either way you want to do it, but you can check it. All right, so the rest of these are yours to do. Y'all have fun with this. Make sure you're showing your work on your paper because you know you're going to take a picture with it, right? But do check your problems. So make sure that you're checking them. And here are the answers to the first page, but make sure you've done them first, right? Because you want to make sure that you've tried them first, because on test day, you've got to be able to do it yourself. But I do want you to check your answers because it's really important to check to make sure you're doing them right and not making silly mistakes along the way. And that's how you learn, is you just kind of go, oh, I got it right, or oh, I made some little mistake here and I got to remember not to do that mistake again. Okay, so there's that one. Remember, you're going to pause the video and not come back and check these until you finish them. Here's the second page. Everybody got them? Okay, you can pause it when you need to. Y'all have fun. Bye.